So yes, Q1 across, so we name this Q1 across the charge for capacitor 1 microfarad, which is this one. And we put the same formula, Q is equal to C times V, and I give the name for that charge as Q1, which is 40 microfarad, using the same formula. And C across, C over here is 1 microfarad and the voltage is 40 volts. Now let's look for the charge across 2 microfarads. So again the same thing, we just write here the charge across 2 microfarad capacitor, and that's going to be, I'm going to name it as Q2. So I'm just putting the value of my the capacitor and naming that charge. I'm sorry. Okay, so again the same formula, which is Q is equal to C times V, and Q2 is equal to, so the C capacitance is 2 microfarad and voltage is 40. Okay, so the value for this charge across 2 microfarad capacitor is 80 microcoulombs. So that's the answer for your charge across 2 microfarad capacitor. Now if you look here, since we have found the charge for this line, now we need to find the charge across this line, the second branch. So the second branch, I have just simplified it into one capacitor, and that's 3 microfarad. So I'm just going to do this one. For 3 microfarad. And I will be naming this as so it's going to be charge across 3 microfarad capacitor. And that's going to be again Q3. So I'm just putting this 3 value, the value of this capacitor, as the name. So Q3 is equal to again C times V. So that's going to be Q3 is equal to, C is 3 microfarad and voltage is, you know, it's 40 across a parallel circuit. It's going to be the same for all the branches. So it's going to be 120 microcoulombs. So this Q3, this is the charge, which is 120. 120 is the charge across 6 microfarad capacitor and this 6 microfarad capacitor as well. Now we know that the voltage is same across 2 terminals in a parallel circuit. But what about the voltage across each of these capacitors, since these capacitors are placed in series pattern? So we need to check the voltage across the capacitors connected in series. So for that, we know that the total is going to be 40, but V1 or V6, let's name it as V1. So V1 plus V2 is going to be equal to 40. So when we do that, I'm going to do it on this side. So here, so we know that this branch is 40 voltage, which is this, okay, but we don't know what is across this two capacitors and the terminals of these capacitors, okay. So we need to find the voltage across each of the capacitors. So how do we do that? We just do the normal same formula. Q is equal to C times V, and we know that Q is we know that C is 6 microfarad, and the voltage we don't know, so we need to find that. So I put V as it is, and the Q is 120 microfarad, because we just found that it's 120 across this whole line. So when I rearrange the equation and I keep V as the subject, so it's going to be 120 divided by 6, and that's going to be 20 volts. So you have 20 volts for 6 microfarad capacitor, and this is also same. So the voltage is just going to be the same for the other one. So we can see the V total is actually equal to V1 plus V2 in a series circuit, because this two capacitors are connected in series. So it's going to be 20 plus 20, and the total voltage, which is 40, that you get in this branch, and that's right. So you get it as 40. So it's right. Yeah, so that's it.